Let's go through just a series of kind of miscellaneous alkene oxidations. Some of them are cleavages, just all kinds of reactions. So here's a reaction that we've seen before. Just take an alkene, you treat it with OS4, OS is osmium tetroxide, and you get the diol from the alkene. This is a syn addition. There's actually another set of reaction conditions that'll do this. And this reagent, as it turns out, KMnO4, potassium permanganate, for some reason seems to be a favorite of standardized tests. Potassium permanganate, if it's dilute and basic, little sodium hydroxide in there, you actually get the exact same product as if you did an osmium tetroxide reaction. So sometimes it's nice to have multiple different reagents to give you the same products. Okay, so these aren't oxidative cleavages because we haven't actually broken the pi and sigma bond. We've just done an oxidation to the alkene. What else do we have? Let's take the same alkene, and now let's treat it with osmium tetroxide and sodium periodate. Sodium periodate is able to react with this diol and actually cleave the sigma bond between. So now we actually get cleavage of both the pi bond and the sigma bond. Osmium tetroxide base breaks a pi bond, sodium periodate breaks a sigma bond, and we get this dialdehyde. This is actually the same product as if we did this alkene plus an ozonolysis with a reductive workup. We get the same aldehyde out. So these are interchangeable reagents. Now we'll throw one last set of conditions in here. Now let's do potassium permanganate. Maybe it's more concentrated, or we throw in some heat. So this is not, as we saw on the upper right, dilute and basic. This is now more concentrated and maybe with heat. And what happens is we don't get the diol, which we saw in the upper right, but now instead we get cleavage of that carbon-carbon sigma bond between the alcohols, and we get the dicarboxylic acid. Note, this is the same product as if we took this alkene and did an ozonolysis on it, and instead of using a reductive workup, we used the oxidative workup. Sodium peroxide, sodium hydroxide, and water, and we would get the exact same product. So that's just a set of commonly encountered oxidative conditions, most of which also cleave the carbon-carbon sigma bond to the alkene to give a range of different products, oxidative products.